Morning everyone. Good morning. Shall we begin the session? Yes, today's topic is chapter number 7, that is linking. That is how to link the object module or how to link the object file with the other files or within the next module. That is chapter number 7, linking. Then chapter number 7, this is 7.1. Okay, alright. Now these are the various topics in this. For example, one of the topic is compiler drivers. Yes, this we have studied in chapter number, I think 4. Yes. Then static linking, how to link and how to compile, then load the executable file. That is a static linking. Then object files, what are the object files, obj files, relocatable object files, then symbols and the symbol tables. Then symbol resolution, relocation, executable object file, that is exe file, then how to load that file, dynamic linking with the shared libraries, loading and the linking shared libraries from applications, then the position independent code PIC, and at last there is a tools for manipulating the object files. What are the various tools that is available for manipulating the object files that is available in the PIC. And then at last there is a summary, bibliographic notes, and problems. Now first of all, what is a linking? So linking is a process of collecting and combining various pieces of code and data in a single file. So when we collect multiple pieces of code and data in a single file, that can be uploaded, that can be loaded or uploaded, copied into the memory and executed. And whenever linking can be performed, that can be done at the compile time, and when the source code is translated into the machine code at the load time, and when the program is loaded into the memory, that is done by the loader. This link can be done at the compile time, load time, whatever the loader, whatever the runtime that is used by the application programs. And on early computer systems, linking was performed manually, and on the modern systems, linking is performed automatically by the programs known as linkers. That automatically means when we compile, when we use Alt F4, Control F9, Alt F9, then automatically during the compilation, during the machine code conversion, automatically the linking can be done in the linker. And linkers can also play a very crucial role in a linking. So linking can also play a very crucial role in the software development because they enable the separate compilation. So instead of organizing a large application as one monolithic source file, we can also decompose into the smaller, more manageable module that can be modified, that can be compiled separately. And when we change one of these modules, we simply recompile it. So whenever we combine, whenever we change the module, we simply recompile it and relink the application without having to recompile the other files. Other files in the sense, whatever the file that can be taken to recompile that. And linking is usually handled quietly by the linker, and it's not an important part or issue for the students who are building small programs in the introductory programming classes. So why we were doing learning about linking? Understanding the linkers will help you to build large program. Understanding linker will help you avoid the dangerous programming errors. So whenever we understand the linkers, that can be help to build large program. Whatever the new program, whatever the large program that can be available, so that will available to large or build the large programs. And then programmer who build large programs often encounter the linker errors caused by the missing modules, missing libraries, or incompatible library versions. Then you understand how a linker resolves references, what a library is, and how a linker uses a library to resolve the references. The next is understanding the linkers will help you avoid dangerous programming errors. The decision is that Unix linkers make them resolve whatever resolve symbols, whatever the symbol reference that can slightly affect the correctness of your program. Then program that incorrectly define the multiple global variable that can also pass through the linker without any warning that is available over here. Then understanding the linkers will help you to understand how language scoping rules or how the language scoping rules are implemented, what are the various factors that implement the rules. For example, what is the difference between the global and the local variable? That is also done by the scoping rule, that is also understood by the linkers. What does it really mean when you define a variable or the function with the static attributes? The next is understanding the linking will help you understand other systems concepts also. What are the executable files, what are the concepts, what are the data that is available that is produced by the linker that can also play an important role in the system functions such as the loading, running the program, virtual memory, paging, and the memory mapping. Then understanding the linking will enable you to exploit the shared library. For many years, linking was considered to be fairly straightforward and uninteresting. And however, with the increased importance of the shared library, whenever we are using or whenever we are increasing the importance of the shared library and the dynamic linking, linking is a sophisticated process that provides a knowledgeable programmers with significant powers that is used to exploit the shared library. For example, many software products use the shared library to upgrade the shrink wrap binaries at the runtime. And it also used by the web server that rely on the dynamic linking of the shared library to serve the dynamic content. Now this chapter is also based on this compiler driver, compiler linker driver that is used over here. So it consists of two source files, main.c and swap.c. Main function called the swap, which swap two elements in the external global array, main elements in the sense two elements that is used in the external global array buffer. And when we grant it, this is a strange way to swap two numbers, but it will serve as a running or small running example throughout this chapter that will make more important point how the linking works. And most compilation system provides a compiler driver that includes or that invokes the language processor, preprocessor, compiler, assembler, linker as needed on the behalf of the user. For example, when we talk about the program using the GNU compilation system, we might invoke the GCC driver by tapping the following command to the shell, that is gcc 02g0 main.c swap.c. For example, 7.2 summarizes the activities of the driver as it translates the example program from an sky value file into the variable that is scope or that is used with the executable object file. The next is CPP, other arguments, main.c, tmp, main.i. The driver also runs the C compiler which translates main.i into an SKY assembly language, that is the file main.s. Then CC1, tmp, main, I, main C02 other argument that is also used with the tab. This is the main.c, this is the swap.c. This is for the swapping, this is for the main. Then these are the translators, CPP, CC1, AS, then translator, CPP, CC1, AS. Then main.c, swap.c. There is a source file that translates, then translators, then main.o, relocatable object file, then swap, relocatable object file, then linker, ID, for the fully linked executable object file. There is a translator, CPP, CC1, AS, then main.o, swap.o, then linker ID, that is a fully linked executable object file. That is a static linking. This linker combines relocatable object file to form an executable object file P. And the driver goes through the same process to generate swap.o, and finally P runs the linker program ID which combines main.o, swap.o, the necessary system object file to create the executable object file P. Then IDOP that executes the file that is used with the system object file argument. Then DNP main 0, whatever the main function that we are unable, that is used with the main.o and the swap.o. And to run the executable P, what is the name that is used over here? The next is the static linking. The one is the compile linking or the compiler driver, then static linking that is done at the runtime. So whenever we are using, yes, this is the collection of the relocatable object file in the command line argument that generates input or relocatable object file various code, and instructions are in the one section, initialize global variable in the other section also, initialize variable that is done in the section or the another section. So to build the executable, the linker must perform the two main tasks. One is the system or the symbol resolution. Symbol resolution doesn't, so how to convert, how to change that one. Then relocation, compilation, assembler, generate the code, data section. That starts at the 0, and the linker relocates the section by associating a memory location with each symbol definition with the each data that is available with references to each memory so that they point to this memory location. The next is the object files. This is another important concept. Okay. Yes, first part is an object file. First of all, comes in the three forms. One is a relocatable object file that contains binary code and the data in a form that can be combined with other relocatable object files at the compile time to create an executable object file. Then executable object. One is a relocatable. That means we can relocate, we can use, or we can say we can reuse that object code to compile to create our executable object file. Then executable object file that contains binary code and data in a form that can be copied directly into the memory and executed. Whatever the file that is executable, whatever the data that is executable that contains the binary code and data in a form that can be copied directly into the memory and executed. Then shared object file, a special type of the relocatable object file that can be loaded into the memory and linked dynamically. That means we can share the files, we can share the data, whatever the data that we are using, that can be loaded into the memory. So first of all, it's the duty of the registers or the primary memory to load into the memory, and then link dynamically. Dynamically means, yes, very good, at the runtime. And static means at the compile time. Yeah, this can be done either at the load time or the runtime. The next is relocatable object files. Yeah, this is the detailed explanation that we have already done on this. Okay. So just read out these. Yes. Now let's start again. Next part is the relocatable object files. Yes, we have already done that. It uses the ELF relocatable object file, and the ELF in the header begins with the 16-bit sequence that describe how the word describe or how the data describes with the word file and the byte ordering of the system that generates the file. And the rest of the ELF header contains information that allows the linker to parse and interpret the object file. That includes the size of the ELF header, object file type, relocatable, executable, shared, machine type, file offset that is used with the section file, section header data, size and the number of the entries in the section header table. And the location and the sizes of the various sections are described by the section header table, which contains a fixed size entry for each section in the object file. And sandwiched between the ELF header and the section header table are the sections themselves, and the typical ELF relocatable object file contains the following sections. One is the .text, that is a machine code of the compiled program, then raw data that reads only data that is used as a format string in the printf for the printf statements, and the jump table for the sys statements. Then one is a data, that is the data, then next is the .bss, then .sys or the syntab or the symbol table, that is, then rel reliable text, then rel data, then debug for debugging for finding out the errors, and line Then str or the string tab or the system table, that is used in the sim tab, that is used in the debug section for the section names in the section headers, and the string table is also used for the compilation of the null terminated character string. The next is symbols and the symbol tables. That uses the global symbol, that uses the local symbol, that uses the static symbol, that uses the non-static symbol, that uses the predefined, that uses the reference, that uses the module symbol, whatever symbol that is available in the C function, the global variable that is acquired, that is taken out with the static attributes. And these symbols are visible anywhere, anywhere in the sense everywhere, anywhere within the module M, but cannot be referenced, but cannot be used by other modules. And the sections in an object file and the name of the source file correspond to the module M also gets a local system or the local variables. And that is important to realize whatever the symbol we are taking out, whatever the data we are taking out, that is the same as the local program variable. And the symbol table in the .sim tab does not contain any symbol that correspond to the local non-static program variable that are managed, or these are managed at the runtime on the stack and not of the interest to the link. This is another static variable example or local variable int x, static int x equals to 0, return x, then int g, static int x equals to 0, return x. In this case, the compiler space or compiler allocates a space for two integers, that is int.data, and exports a pair of the unique linker or symbol to the assembler. For example, it might use x.1 for the definition in the function f and x.2 for the definition in the function. So one is the x.1, one is the x.2. x.1 is used in the function f and the x.2 is used in the function g. Then symbol tables reassembler that we have done. Then this is the type of struct function. Then symbol resolution. If the two symbols or the function name have a variable have a same function name, how they are resolved, how they are used, so that is resolved by using the or by carrying out the symbol resolution. Linker resolves the symbol references by associating each reference with exactly one symbol definition from the symbol table of its input. Relocatable object file symbol resolution, that is straightforward for the references to local symbol that are defined in the same module as a reference. And the compiler allows only one definition of each local symbol per module. That generates or that ensures about the static local variable which gets local linker symbol and has a unique names. And resolving references to global symbols, however, is very trickier, and when the compiler encounters a symbol that is not defined in the current module, it assumes that it is defined in some other modules also, then leaves for the linker to. And if the linker is unable to find a definition in its input module, it points out an error message and terminates. For example, if we try to compile and link the following source file on a linked function, for example, void int main, then foo returns 0. Then the compiler runs without a hitch, but the linker terminates and it cannot resolve the reference to the